Hello guys. All right, so we're going to be doing a couple problems that people sent through e-learning. All right, so the first problem we're looking at, right, it's one of your molar mass problems, right? And so when you're thinking about molar mass, right, you're typically looking at the formula that's given, and you're probably going to be adding up, right, its individual mass amounts, right? So with Na, there's two Nas, right? X is a unknown element, so we're trying to find that, right? And there's two of those, and then there's 7 oxygens, right? So the ultimate goal is to be able to add up all those values to find your molar mass, right? So what we're given here is 0.375 mole, the the formula, and then the actual mass, right? So here's how I would first start this, right? So excuse my handwriting, it's not great. So 375 mole is what we have, right? And so typically you want to multiply that by the molar mass 1 mole, right? Equals. And so they've given you the actual weight of it, right? So if you were to do this, and if you were to solve for molar mass, you end up getting a value that's about molar mass. If you solve for molar mass, right, you get 261,973, something around there, right? But more importantly, now the next step, identifying that, is more important. If you have the molar mass, now what are you going to do, right? The best way to solve this problem would now be to look at that formula, right? Na2X2O7, and start seeing how we could find this X, right? So I would do is 261.973 minus, right? What can I subtract out of here that's going to leave me with the X? And that's going to help me find what element X is, because I can look on the periodic table and see which one has the corresponding, mass. So what I would do first is, I know that we have 7 oxygens, right? 7 times, what's the mass of oxygen? It's about 16, right? So if I do that, I end up with about 149.973, right? And so the next step after that, right? So we got rid of this, right? So now what are we going to do? We got to get rid of this so we can just have our X alone, right? So now what I would do is 149.973 minus, how many sodiums do we have? 2. What's the molar mass of sodium? It's about 2.299. If you could put that to 23, that's fine too. And so that leaves us with about 103.993. Math might not be perfect, right? So if we got rid of this and we got rid of this, right? What does that leave us with? Just the X2, right? And if there's 2X, right? If there's 2X elements, right? If there's 2 of them, the best way to do this would be, divided by 2, right? Because we have 2 of them. We only want to see what the mass of 1 is, right? And it gives us something like 51.9965. Now, here you have the final weight of just 1 X, right? And if you look at the periodic table, you'll find out that the actual element that has the same atomic mass number is 51, is chromium, right? Chromium is the actual element. So it's Na2Cr2O7 is your final answer, right? So you want to find the molar mass by taking the moles and the actual mass, right? And then start subtracting what is given, and then it'll leave you with just X, right? And then when you find just X, that mass is corresponding with one of the elements on the periodic table. So hopefully that's helpful. Hopefully you guys understood that. It's a pretty simple problem. It'll work the same way for all the other elements, right? You don't have to change anything, but sometimes the Na might be changed around or the O might be changed around. So just change these in correspondence, but ultimately you'll be able to find the answer the same way, right? Once you've isolated just the mass of 1x, you can find the corresponding element on the periodic table. So hopefully that's helpful. If you have any more questions, just feel free to email me.